Hi everybody, I'm AG and welcome to Unit 4, Proposition Logic. A proposition is any statement who can be evaluated as true or false. In that way, this is true, those are false, and this is not a proposition, so cannot be evaluated. A composition of propositions right here. In this example, we have 4 primary or primitive sentences connected with words such as and, or. These words are called logic operators. For now, we will discuss the AND operator, a representative of a conjunction, the OR operator, a disjunction, and NOT that represents a negation. In computer science, these operations are denoted by each of these symbols. We are going to refer to them with simple uppercase words. Now, an operator represents an operation for a single or multiple values and will output true if only if the 2 input values are true. Otherwise, the result will be false. OR will output true when at least one input value is true. NOT will output the opposite of the input value. By example, according to its input, evaluate each of these 3 results. This statement is false and this one is true. So, following the AND logic, the result is false. This is false and this is true. So, following the OR logic, the result is true. And finally, this true statement after a negation becomes false. The most efficient way to order and perform a logic operation is by a truth table like this one. We are going to replace the NOT word by an exclamation mark. So, having all this data, find the output for each logic operation. The negation of B. If B holds true, the result is false and vice versa. The OR operation needs at least one true input to be true, and this one is just a negation of this result. Now, in some way, the conditional statements can be seen as logic operations as well. The conditional only will output false if the first statement is true and the second is false. And the biconditional only will output true if the 2 statements are true. This sounds similar but differs from the AND OR operations. By example, a girl with an umbrella. A is the dependent statement and B is independent. She can be without her umbrella and it still rains. But Cecile never will be with umbrella without rain. In the second biconditional, the 2 statements are interdependent, so the only way that becomes true if it's raining and she holds her umbrella. Here, the conclusion is a statement that results from a single or multiple statements that are called the arguments. The only way that a conclusion is true is if all the arguments are true. The symbol to denote this operation is this one. We are going to use the word proof to refer that. In that way, given this data, find the conclusion value. First, resolve all inner operations. We have a conditional here. To have a true conclusion, all arguments must be true. And because A is false, the condition doesn't match. Here we introduce the idea of a propositional function that is slightly different from a simple function. The domain will be every element who can be evaluated, but in this case we don't have something like the range. We have the truth set, and here will be every element that returns true throughout the function expression. By example, in these 3 propositional functions, the domain every real number, but the truth set only the numbers who satisfies the condition. So, the idea of a propositional function leads us to the quantifiers concept, and when you see this symbol right here, this is saying that all the set A elements satisfies the propositional condition. And this one right here is saying that not all but some A set elements satisfies the proposition expression. Also, we have propositional functions involving multiple variables. In this example, writing every A set element in X and some A set elements in Y, we are sure that the output will be always 5, but not every combination of two A set elements is 5. 3 plus 3 is 6, and that is not in the truth set. Just take care about this, okay? If you pay attention to all the examples in this unit, I'm sure you are going to clear the following test by far. Let's go. Question 1. We have these 4 propositions and we must write a result for each of these operations in plain English. Obviously, in all these the subject is also Susan. If Susan is vegan, the negation is Susan is not vegan, and the B statement still the same. A and C like this. For the last, solve the inner operations first. B or C is. She usually orders burger or fruit salad. Along with the other conjunctions, it will be like this. Question 2. Having the following values, solve the logic operations and complete the truth tables. I and J both are true. The K negation is true. It's enough to produce a valid result. The conditional between I and J negation is false. The biconditional on L and M is also false. The negation of L is true, but M still false. The conditional between this result and M is true. This is false and these two are true. Now, having the same values, determine each conclusion on every argument set. Remember, a conclusion will be true only if all arguments are true as well. Question 4. We must find the truth set for every propositional function. In other words, the set of numbers that will produce true as output on every expression. First, there is not element here that results in 0 subtracting 5, the empty set. 2. If we add 4 to every element, it will result greater than 8. 3. Some value in the set S is greater than another set S element. After subtracting 2, 9 minus 2 is 7, that is greater than 6. 4. Some value in the set S is less or equal than 0 after subtracting 6. This is the 6 itself. This has been all for today's video. Thank you very much for watching our video and stay tuned for the next coming unit.